Welcome back to the Advanced Microcontroller series. In today's session, let us discuss about microcontroller interfaces with ADC. In the previous session, we discussed about single channel detection. But in today's session, let us discuss about multi-channel detection. So here is the code, and this is the main function. Control will go to the init config, then it will go to the CLCD code. So here I am not going to explain this initialization because we already discussed this in the CLCD episode. And next, control will go to the ADC function. So here, so in the initialization we are not changing anything, same initialization like previous code, but here we have done some changes. Read ADC function. So when I calling a read ADC function, here passing argument channel. So when we calling read ADC function, here we passing argument channel. So in the data sheet, before that, which are the bits used for the channel selection? Let's see using the data sheet. So here analog to digital converter. So here you can see bit number 5 to bit number 3. So these 3 bits are used for the channel selection. So if you want to select the channel 0, then what we need to do? For these 3 bits you need to write 0 0 0. For channel 1, for these 3 bits you need to write 0 0 1. Channel 2 0 1 0, channel 3 0 1 1, channel 4 1 0 0, like that you need to write. So here we having option, isn't it? So which channel user want to read? Pass that as an argument. So here you can see the same thing here also. So for this channel you have to define some macros. So for channel 0, 0x00 means binary value of 0 0 0, and for channel 1 0x01, and channel 2 channel 3. So if you want more channel, then you can add it here. Short, here you can see the short read ADC function, and here we defining variable, and this line which is used for selecting the required channel. So here we using addcon 0 register. So we are selecting the required channel. So how it is selected means by using the addcon 0 register we have to select the required channel. So in the data sheet here you can see this is the addcon register. So here we having 8 bits in the addcon register. So we having 8 bits. So let's discuss about this. Okay. So total we having 8 bits. So this is the bit number 7, bit number 6, then bit number 5, bit number 4 and bit number 3. These are the channel select bits. And next is the bit number 2, and next is the bit number 1 and bit number 0. So total we have 8 bits, isn't it? Now let's assume we have some unknown data. So for the unknown data, what we are doing, we are writing as X. So X means what? This is the unknown data. Okay. So for all 8 bits we have to write, we have to assume some unknown data. So out of these 8 bits, here you can see bit number 1 is the unimplemented bit. Now which bit is used for the channel selection? Bit number 5 to bit number 3. These 3 bits are used for what? Channel selection, isn't it? So if I want to select the channel number 1, then what I need to do? So we need to write 001, isn't it? In the data sheet they mentioned. So if I wanted to select the channel 1, then I need to define macro 0x01 and this value connected to the variable channel. So whatever this value, we can write the 001, isn't it? So this value we have to put here for bit number 5 to bit number 3. So before selecting any channel, we have to clear these 3 bits by retaining the rest. What do you mean by clear? Clear means we have to write it as 000. By retaining the rest means what? We need to write 111 for rest bits, and for channel select bits we need to write 000. Only 3 we having, right? Bit number 5 to bit number 3 and rest bits are 1. So now 1100 means what? That is nothing but 1100 means C and 011 means 7, isn't it? That is what? 0xC7. So whenever you want to clear any bit, use AND operation. So here I am going to use the AND operation. AND operation. So here let's use AND operation. X and 1 means X. X and 1 means X again. X and 0 means it is 0. And again X and 1 means X, X, and X and 1 is X. So this 1, can we write it like this? Addcon 0 is equals to addcon 0 AND operation, right? So addcon 0 and 0xC7. So can we write like this? The result is stored in addcon 0. So now let's select channel. So whatever channel is there, let's put it here. So we need to write channel also. We need to select the channel also. So here I am going to write OR operation, or then channel. Yeah. So it is going to select the channel. So I wanted to select channel 1. Then I need to write 001, isn't it? For channel 1 we need to write 001. Now here I am going to write 001. Can I write like this? No, these 3 bits are not for the channel selection. So we need to write it here, isn't it? Bit number 3, 4, 5. So here we need to write. So let me erase this and also this. So here we need to write 0 0 1. Yeah, so you will end up by selecting the correct bit. So 0 0 1, isn't it? So here what we did, left shift by 3, isn't it? So here we need to write channel left shift by 3. So here I am going to write like this. So here you can see the same thing we written, selecting the required channel. And so in the main function, here you can see read ADC, here channel 0. So here we are selecting channel 0, which is connected to the potentiometer 1. So if you are varying the potentiometer, so in the PICSimLab microcontroller we having two potentiometer. So if you are varying the first potentiometer, then what will happen? Read ADC function will read that value, and that value stored in ADC reg value, this variable. So that value stored in this variable. Same thing here also. Here we using pot 2, potentiometer 2. In the previous case we are dealing with LED, but in this case, so here whatever result we got, ADC reg value is there, right? So that is displaying that value. So here what we are using, CLCD display we are using. So here you can see display function is there. So it having two arguments. One is ADC reg value 1 and another one is ADC reg value 2. So this ADC reg value will display the integer value. So can we print integer value using CLCD? No. In CLCD we can display only characters. So what we need to do, we have to convert the integer value into the ASCII. So we have to convert this number into string. Then we have to print. So here you can see we are using char buffer of 5. So why 5? It having maximum 4 character and including 1. So here we return 5. And next here you can see C0. What do you mean by C0? It is nothing but channel 0. And this is the logic. Here you can see this is the logic for the convert integer value into ASCII. And here you can see it will print the buffer in second line, third position. Similarly, here another CLCD print statement is there which having C1 means channel 1, and this is the logic to convert integer into string. So it will convert integer into string, and this is the print value. So print statement, it will print on the second line, 12th position. So this is what position, and this is the line number. So this is the code. So this is about multi-channel detection code. Okay, so let's build. So open PICSimLab and file load hexa file multi-channel detection, and this is the output. So here you can see ADC test. channel 0. So this is the channel 0. So vary the pot. So here you can see it is varying, isn't it? And when it reaches 5 volt, it prints 1023, and when it reaches 0 volt, it prints 0000. Same thing here also. This is the second part 2. It reaches 5 volt now. Here you can see 0 volt. When it reaches 0 volt, it prints 0000. So that's all about the multi-channel detection code. And next is the data storage. So what do you mean by data storage? So storage is depending upon what are you trying to store. So your data could be data or code. So if code, then which memory we are preferring for code? So for code we are preferring NOR flash. So NOR flash is the programming memory. And if your data could be data, then which memory we are preferring? So it depends on the how much is the data, isn't it? It depends on how much is the data. So if your data is big quantity and blocks of data, then you can go with the NAND memory. If your data is huge amount of data or few bytes of data, then you can go with the EEPROM memory. So let us discuss about built-in or internal EEPROM. So mostly used in every embedded system. The size and component of storage is depending upon the requirement. Modern controllers has built-in data storage, that is EEPROM and data flash, etc. So let me open the data sheet first. Let's discuss about this along with the data sheet. So data, EEPROM and flash program memory. So here, so let's read this and understand. So the data EEPROM and flash program memory. So it is readable and writable. So it will do both operation, readable and writable during the normal operation, readable and writable. So this program memory is not directly mapped in the register file space. So how it is mapped? It is directly addressed through the special function register. So here we having 6 special function register which is used to read and write this memory. So when interfacing to the data memory block, EE data holds the 8-bit data for read or write. EEDR holds the address of the EEPROM location being accessed. So these devices have 128 or 256 bytes of data, EEPROM. So with an address ranges from 00 to FF. So for 128 bit address ranges from 80 to FF. So our microcontroller, so PIC microcontroller, we having EEPROM, right? That is 256 byte. Means address ranges from 00 to FF, isn't it? So on each location or address, how much is the maximum byte? 1 byte. So total location or address is 256. So let's implement up counter on each key press. So when you press the key, value should increment. So count up to 9 on every key pressed. So once count exceeds 9, it should be reset. So it's roll back it to 0. So here we have options. First option, to store count into internal EEPROM. First option is to store count into internal EEPROM, means write into the internal EEPROM. To save value, what we need to use? We need to use the write operation to save the value. And second option is what? To restore count value from EEPROM. So to restore count value from EEPROM, this is the second option. First one is store, second one is restore. And what is third one? That we'll see later. So we having two options, one is store, one is restore. And here we using digital keypad. So user keys are which one? Digital keypad, isn't it? So when user press which one, what will happen? Save or store. So first option. If user press switch to, then restore. If user press switch 1, then store. If user press switch 2, then restore. If user press switch 3, then increment. So in our compiler, so which compiler we are using? XE8, isn't it? So it having built-in function to write into the EEPROM and read into the EEPROM. So where is the prototype of function is mentioned? It is mentioned in the header file. So here we having xe.h. So right click, then here we having one option, that is navigate, then go to declaration, and here you can see PIC.h. again right click, navigate, go to the declaration, and here where is EEPROM? Here you can see EEPROM routines.h. Right click, navigate, go to the declaration or definition. Now scroll down to below, bottom. So here you can see EEPROM read function and write function. Here we having, right? Copy that function and I will paste it here. So these are the write function and read function. So this is what read function. So in the write function we having two argument. It's taking two argument. One is address and one more is the data or value. Value means what? What data you want to write. So now assume my data is x. So data, I don't know which data. So I am considering it as x. Okay. So I am randomly considering one data. I wanted to store this. Where I need to store? this is my address 0x00. Now this is my data and this is my address. So EEPROM write function having these two arguments. So at a time you can pass 1 byte, and in the read function we having only one argument. It's taking one argument. So here what is the return type? Unsigned character, isn't it? So unsigned character means 8-bit value or 1 byte value. So whatever value available in this address, that will return here, unsigned character EEPROM read. So for example, so I'm writing ch is equals to EEPROM read 0x00. So I wanted to read from 0th location. If I execute this, whatever you return in 0th location, that will be going to read. Okay, so let's close this and open the code. Data storage, internal EEPROM. So here is the source files. So here you can see how many peripherals are used in this code. Digital keypad, SSD. So if you wanted to display in CLCD, you can use CLCD, but here we using SSD. Okay, and internal EEPROM and digital keypad. We can display using CLCD, but here we use it SSD. For internal EEPROM, we having built-in function, so no need to worry about the initialization. And this is the main.c. So this is the character EEPROM test. So this is the variable declaration, count equals to 0. If you press the switch 1, then what will happen? Save or store. If you press switch 2, then restore, means it is resetting to 0. If you press switch 3, what will happen? Incrementing, and when it reaches 9, again it reset to 0. So this and it returns the count value. So what will happen? After it reaches 9, it resets to 0 and return the count value. And here you can see SSD digits. Sorry, this is SSD and this is the digits. So key equals to read digital keypad of state. So it increase when you press the key press, isn't it? That's why here we using state. And here you can see SSD of 0, SSD of 1. What it means? So here we extracting each count number, isn't it? And display using the SSD. Extracting and displaying using the SSD. So here production, clean and build project. Go to the PICSimLab Simulator load hexa file. So here I'm going to choose distributive. Build is not successful. We having some error. Let's see what is the error. So here you can see on line 59. So expected expression. So here, yeah, so here is the mistake. I'm going to delete this. Then production clean build project. Let's see. Yeah, build is successful. Now go to the PICSimLab Simulator. Then again you need to select the file, distributive default production. Then yeah, see, now we having three switches, isn't it? Switch 1 is used to store or save. Switch 2 is used to restore, and switch 3 is used for increment. So in the this one macros, we defining the which are the macros we used. So here you can see keypad port B. For switch 1 we are using which one, and for switch 2, switch 3, sorry, we defining, isn't it? So now go to the PICSimLab Simulator and press switch and see the output. So we having three switches, right? So if I press switch 3, then increment happens. So 1, 2, 3, 4, 5, 6, 7, 8, 9. When it reaches 9, again it reset to 0. Here you can see it is reset to 0. Again I start to press switch 3. Now switch 1 is used to save or store the data, isn't it? I am pressing switch 1. Then again I will press the switch 3 for increment. Now I will press switch 2 for restore. It shows 4. Why? Because if you press switch 1, it will store the count value where we storing count. So now again I will increment and I will save or store this count value. Then I will again increment this value by using switch 3. If I press switch 2, again I will get 7, isn't it? So this is about the EEPROM. So that's all about the data storage. And in the next session, let us discuss about communication protocol. That's all about the today's session. Thank you all.